for this assessment, we're asked to use these vectors and find the smallest angle between each one. So the first one, E and F. So placing them tail to tail. See that E is 30 degrees from the positive horizontal axis, and then F is 60 degrees from the positive horizontal axis. So therefore, is just a 30-degree difference between these two. And just here, I did some calculations here to show that this missing angle would be 30 degrees. So moving on to the next one, we have L and K. So L is 130 degrees, and then placing them tail to tail with K. So K is 50 degrees, so it's kind of pointing opposite direction. So the angle would be 180 degrees for this one. Moving on to J and F. Well, J is at 100 degrees, and then F is, where is F? We have F is 60 degrees. So therefore, we have a larger angle here with J, which is 100 degrees. There's about a 40-degree difference between these two. And here we get 60. We want to find this angle we can say is X. So on for X, we get 40 degrees. Moving on to the next one, we have J and N. So J is at a 100-degree angle, just use this 100 degrees, and N is 10 degrees from the vertical axis. So it's 10 degrees between the vertical axis and 10-degree difference here. So they combine, add both angles up, we get a 20-degree angle. And here we have K and N. So K is 50 degrees from the positive vertical axis, and then we have 10 degrees between the vertical axis and vector N. So combine these two, we get a 60-degree angle. And for our last one, we have K, which again is 100 degrees, so it's 50 degrees away from the positive vertical axis. And then we have this angle here, which is E, which is 30 degrees away from the positive horizontal axis. So we know that the positive vertical axis and positive horizontal axis forms a 90 degrees. So you can subtract 30 degrees, which is a remaining 60 degrees. Combining those two angles gives us 110 degree. The smallest angle between these two would be 110 degrees.